COVID-19 has completely disrupted the world. Whether it's patients overwhelming the hospitals, or whether it's people being told to stay home. And there's one very key thing that I think is not right. And that is that there are not enough doctors to help prescribe medication to people who have current chronic diseases and who know they have these diseases. And because they have that, they can't go outside to get the medications that they need because they have the risk of contracting the disease. And there's no other option for them because if they stay home, they may possibly not have enough medication to last them throughout this pandemic. And therefore, that could be fatal. And if they get coronavirus, that could also be fatal. So there is a huge problem here. And over the past few months, before coronavirus even, I've been focusing on my passion of drone technology, and specifically autonomous drones. And I think that we can combine autonomous drones to help solve this small problem to at least help these people who have the current chronic diseases throughout this pandemic. I was starting to think about how to build this drone. And I've always been in the drone hobby, and I already know a few of the parts, but going from a standard drone to an autonomous drone is quite a big step. And one of the first things that you need is a GPS. A GPS module is a module that you use to detect the geolocation of an object on a 2D plane. And I say 2D because the satellite, which is tracking the GPS, is looking from above. And what that means is you're going to only be able to see the longitude and latitude of the drone and not get the height value, the altitude. And for a car or your phone, that may not matter as much, but with a drone, that's a very significant part to it, is being able to read where it is in a 3D space, not just a 2D plane. So I also began to do research into how I can get altitude. And there's one sensor that allows you to get altitude, and that's called a barometer. And a barometer, what it does is it senses how far off the ground the drone is. And I happen to get a flight controller that is capable of having a barometer on board. A flight controller is what controls the drone. It is pretty much like the motherboard that tells the drone what to do. So the motherboard or the flight controller that I got has a barometer already on it. So that allows me to now have a 3D positioning on where the drone is in space. So now that we've kind of focused on where the drone is in space, we can tell it to do things. And this is one of the very crucial things that I think could be so beneficial to people, is that we can control these drones using an AI software, and that's what makes it autonomous. Is that now that we have an autonomous software that can do this, we can deliver these products with a 3D mapping. So the GPS now has a location, and the flight controller can also update us from a ground station on where it is in 3D space. So we constantly have an update on where the drone is. And this is really important because especially if we are going to be transporting medication from one facility to a person's house who needs a medication, we need to be able to track it and make sure we don't collide with anything. We don't accidentally go to the wrong place. And this is why you still may possibly need some human supervision to make sure that the drone is operating properly. So moving on to the next part of the drone that I researched, and that was the motors. So I need motors that are strong enough to be able to hold a package and also be able to perform decently well and have reasonable flight time. So the motors that I got are what's called a AC motor, and that means that it fluctuates similar to an AC current or alternating current. And that's where you have a current instead of like your standard AA battery, which will give you a direct current, which is just a standard voltage and amp rating that is going directly to an electronic. An alternating current is something that turns on and off through a fluctuating wave. And what that allows you to do is turn on and off certain motors using, or turn on and off certain magnets in the motor to control it. And how the motor works is you have a bunch of different magnets that you can turn on and off inside the motor. And what happens is you can turn on a few of them, and there are magnets around the outside of the rotating part of the motor that attract to that. And once those parts attract, you turn off that magnet and you turn the ones next to it, and now it attracts to that one. And you can see how the magnets around the motor are going to constantly attract the other magnets that are being turned on and off. And we do this with the fluctuating current, like I said. And what controls that is called the ESC. The ESC is an electric speed controller, and it takes a signal, a frequency of that fluctuating wave, and it sends that to the motor. And that way the motor can turn on and off certain magnets to allow the motor to rotate. The faster the motors turn on and off magnets, the faster the motor spins. And that's what the ESC does. The electric speed controller controls how fast each motor spins individually. And the reason why we need to control each motor individually is so that we can operate the drone. So if the drone just had all motors going at a fluctuating speed, but they all moved together, that would be a problem because we could only move up and down. But in order to move the drone around, we need to speed up and slow down certain motors. Let's say we want to move forward. We would have to speed up the two back motors in order to tilt the drone forward. Now that the drone is tilted forward, we have more thrust, keep still going down, but also to the side. And that's going to cause the drone to travel in this direction. So when we speed up different motors, we can cause the drone to rotate and then move forward. So the flight controller takes the information from the barometer, like I said, the GPS, but also a few other key components. So on the flight controller, we also have a thing called a gyro and an accelerometer. These things analyze what angle the drone is at. That way we can speed up the motors, and then once we get to the desired angle, we can tell it to stop. Whereas if we didn't have the sensors, the drone would just keep rotating until it crashed into the ground, which is obviously not what we want. So having the accelerometer and gyroscope telling the flight controller, okay, we need to move the back motors until the drone is at let's say a 25-degree angle in order to travel forward. Now the flight controller can take the data that it has in the autonomy software and figure out where it needs to go. Now that it knows where it needs to go, it can tell the drone, okay, speed up the back two motors, we're going to move in that direction. But there's one key part that I left out there. How does the drone know which way is which? So the GPS does tell you where the drone is in the longitude and latitude, but not which way it's facing. And that is also a very important thing that you need to have on an autonomous drone, a compass. A compass can tell the drone which direction it's facing, whether it's facing north, south, east, or west. And once the drone knows that, it knows to go north towards the target, or south towards the target, or any direction where it knows it needs to deliver a product. Now we have all the sensors in place and the drone is ready. We are ready to now fly. But there's one other thing. We need to program the drone. And I use that with a software called ArduPilot, or you can also use a program called iNav. iNav is a software that allows you to do some basic flight, autonomous flight. But mainly what iNav is for is to have a GPS and compass system that allows you to fly normally, but also be able to do things like return to home, or do things like move to a certain coordinate. However, ArduPilot, which is the one that I've installed on my drone, it does a fully autonomous system. You tell it where it needs to go, and it'll go there. It can also land on its own and take off on its own. These are very important things that we need to keep in mind if you were to try and build a drone like this. I think a drone that is capable of doing autonomous flight and delivering packages not only for personal use, but mainly for medical reasons, because there are people out there during this pandemic who are not able to get the medication that they need. It is too much of a risk for them to be going outside. That is why I think we should implement this in place. Thank you.